Hi everyone. This video is going to demonstrate how we might do a detrending of data using multiple years, and instead of using Excel spreadsheet this time, I'm going to be using the Casio scientific calculator. Now, I must say this is a lot more tedious, this process, so I've done an awful lot of this already. Here's the original question. We have 3 years worth of data. The data is split up into four time periods. Now, notice this one here, that's obviously a typo. It should be Q1, Q2, Q3, Q4 for 2016. So we'll just, I've copied the data values here into my table at the top of the page. So no changes yet. The first thing I did was took an average for the year. So those four numbers there were averaged to 307.5. Likewise, the 2015 data was averaged at 315.5, and the 2016 data averaged at 321.5. Those ones were all pretty straightforward. I then started doing my indices. So I took the 320 from 2014, dividing by that year average of 307 to get this index. The 310 from the second quarter divided by the same 307.5, and likewise those indices there for 2014 were calculated on just the 2014 data with the 2014 average. I did the 2015 data, so 327 divided by 315.5 gave this index. Likewise for the other data from 2015 with the 2015 average. Finally, the 2016 data with the 2016 average. So I now have indices for each quarter for all 3 of the years. This is the bit that matters. I then averaged the first quarter indices and recorded them here. I averaged the second quarter indices. I averaged these 3 numbers here, and then I averaged the fourth quarter indices here. Those are my indices averaged across all the data from the 3 years. Now, I know there are other ways that you can approximate multiple years worth of indices, but they don't give you the same answers exactly. They're approximate. I prefer this method. And for anything more than 3 years worth of data, I would most definitely be using a spreadsheet to automate the process. Now, I then detrended the data. So what does a detrended data look like? Well, remember, anything from quarter number 1 has to be using this index. So I did 320 divided by 1.047, and that gave me the 305.6. I did 327, which is still a quarter 1, divided by 1.047 to give 312.3. Likewise, I did 342 divided by 1.047, which gave me the 326.6. So these numbers here in the indices table, there were lots of digits on the calculator. I rounded at the 3rd decimal place. And then these digits here, they went further as well. Because the original data was hundreds, tens, and units, I have rounded in the 1st decimal place to try and preserve accuracy. So there will be a little bit of rounding, but it's not very much compared with the size of the original numbers. The original numbers were in the hundreds, and I've rounded into the 1st decimal place. It's a very small amount of uncertainty there. So where are we up to? Well, I now have to do a trend line for this set of data. This is where my scientific calculator comes in. And as I've shown you in the past, we can use the stats mode. Excuse me. And I've entered the data here into the data table to save time. Now, there's 2 different ways of doing this. We have 3 years and 4 pieces each. There are 12 data points. I could simply in the X column have gone 1 to 12, counting in quarters. Or the way I prefer is to use the actual years. So 2014, now notice that the data value for the first one, so the 305.6 is this first value, but the time value isn't 314, it's 314.25, because that number is representative of the information at the end of the first quarter. So if we've gathered that data, if we've been measuring data all the way through January, February, March, and at the end of March we've come to that measurement, then that is really a quarter of the way through 2014. Likewise, this number, 310.3, occurs at the end of the second quarter, or halfway through the year, 214.5. This one, 0.75, and the last one occurs at the very end of December 2014. In other words, at the beginning of 2015. So it's a little bit, takes a little bit of thought, but if you remember that those numbers represent information at the end of the time period, then that's why I've put it the way I did. Now, remember from this data table, we hit all clear, then shift, stats, 5 for regression. A and B are the numbers we need. So A is from number 1. I have negative 12,244. Let me just put that down. So I have Y equaled A plus B times X. So my value was negative 12,244. I think that's what it was, yes. Now we'll do B, shift, stats, 5, 2. And it's 6.23, I'll round to 1, 6.231. Plus 6.231 times X. There's my formula that is going to model the trend in this data. So detrended data, that's modeling the trend. Now, the question said, find the indices. Yes. Find the trend. That's my formula. Use the information to predict the value at the beginning of 2020. Now, this is the nice thing about this. The beginning of 2020 is 2020.0. So I can literally write in my time negative 244 plus 6.231. The beginning of 2020, there we go. We just write the year in there. If they had have said halfway through, we would have gone 2020.5. So I'll get the calculator back and we will calculate this. So remember, I could type these numbers, or if I wanted to be a little bit fancier, I could go A plus, and before I hit enter, I'll go back in and pick up the value for B times 2020. And I have the answer 342. Let's write that down. Equals 342. Now remember, that number would be from the detrended value. And it was the beginning of 2020, if you like, it was the end of 2019. I really need to adjust that with that index if I want to go back to a raw measurement. So that's a detrended value. If I wanted a raw value, I would take that number of 342, and this time instead of dividing, I'll multiply by 1.008. So I'll just go multiply by 1.008, and I have 344.7. That's my prediction for the value at the end of 2019 or 2020.0, if you like, beginning of 2020. So the reason I had to use that one is because it matched at the end there. So that is very long and tedious, much easier to do on a spreadsheet than on a calculator. But hey, there's an example of how you could do this. Thanks for watching.